Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze a femur bone for its static structure analysis. This is how the femur bone looks like. This is the thigh bone, as you can see here. This is one of the longest and the strongest bone of the human body. This is mainly responsible for holding the posture straight of the entire body. This bone also works in conjunction with other ligaments, tissues, and muscles to hold the body vertical. This is the lower end of the bone, and this is the head of the bone. This middle portion is called as a shaft. So we will start by double clicking on static structural. We will first go to engineering data. We will add the material for the femur bone. Here are the properties which are required for static structure analysis of the femur bone. We'll add the material as femur bone. The first property that we'll allocate is the density. Value of density is 2000 gram per centimeter cube. Next, we'll go to isotropic elasticity and give the value of Young's modulus in gigapascal. 2.13 gigapascal, and the value of Poisson's ratio. We'll go to project and update project. Next, we'll go to geometry and right click. I already have the geometry made with me, so I'll directly import the geometry. Next, I'll go to model and double click on it. I'll first go to geometry and allocate the material of femur bone. Next, I'll go to mesh and I'll change the sizing. I'll give the element size as 0.005 meter. Next, I'll go to mesh and right click and generate mesh. Next, I'll go to static structural, right click and insert fixed support. Now I'll select the face of the femur bone where I want to apply the fixed support. I'll apply fixed support here, and at the top end I will be applying pressure. Apply. I'll change normal to component, and along the vertical axis, that is X over here, in the downward direction I will apply a pressure of minus 800 Pascal. Next, I'll go to solution and insert deformation total. I also want to see the deformation directional along the x-axis, the stress induced in the body, the strain in the body. Okay, if the x direction is downwards, so I don't have to apply a negative sign, I'll apply a positive sign. That's because of the direction. Now I'll go to solution and solve. So for a pressure of 800 Pascal, you can see here, this is the deformation induced in the body. The value is 0.000107 meter. Now if you want to change the units to millimeter, it is down. Just change it to millimeter. You will see that the value of deformation is 0.107 mm. You can animate and check the result. Next, we will go for directional deformation along the x-axis. You can see here the value is 0.033 mm along the x-axis. Again, you can animate and check this result. You can change here, show undeformed model, and then you can just animate and see. You would see the initial position and the final position such that deformed and undeformed positions can be seen. So this option you can choose from edges. Next is the stress value. I'll change this back to show elements. If you want, you can also see it in this way, no wireframe. So the meshes disappear and you can only see the femur bone. And this is the stress induced in the body whose value is 0.052 megapascal. And the equivalent strain generated on the body is 2.48 into 10 raised to minus 5. This is the highest value and the lowest value is 2.148 into 10 raised to minus 8. You can again animate and check this result. So that's how you analyze a femur bone in its natural condition with its material properties. So with this, I end the session. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.